Today's lesson's over section 5.3b, continuing to talk about evaluating definite integrals. If you would, take a moment, pause the video, and give the warm-up a try. Now that you're back, as you can see, the answer of the following definite integral should be the value of 600. Now we've been talking about definite integrals and finding the exact area underneath the curve. But we also have what we call indefinite integrals, meaning we don't have a start and stop point. They continue on from negative infinity to infinity. And so that is actually representing a family of functions, because now we are able to include the value of c here. And c could be anything, so you're literally talking about all those functions with a constant at the end. Now to go along with that, we'll talk about the total change theorem. So still using the fundamental theorem of calculus, but with that is actually talking about the rate of change. So the integral of rate of change is actually equal to total change. So how much a function is changing from that start value of a to the end value of b. And so we can actually find the total accumulated amount if we are able to know the initial amount and then add it to the amount that has changed. And that gives us that final formula on the bottom. So f of x sub 0 is that initial value or initial amount at that first spot. So like I could have given you f of 0 is equal to 100, and that would be my first spot. So example 1 here wants to know a honeybee population starts with 100 bees and increases at a rate of n prime of t, bees per week. What does the integral from 0 to 15 for n prime of t represent? Well, that is just talking about the increase in the bee population in those first 15 weeks. But then, what does 100 plus that integral represent? Well, that is going to be the total bee population. So if I'm saying that I have 100 bees to start with, and then plus that time after 15 weeks, well, that would be the total population. So example 2 just wants us to be able to find the integrals of these indefinite integrals. So this is going to feel very much like finding antiderivatives. Okay, so I first want to kind of simplify everything out so I can get one term or kind of have separate terms from one another. So it's easier for me to be able to find the integral of these. And so after putting it together to get v to the 5th plus 4v cubed plus 4v, I'm able to take the antiderivative of that and then simplify to get v to the 6th divided by 6 plus v to the 4th plus 2v squared plus c. Letter B, there needs to be a little simplification here, so I'm going to use the identity for sine of 2x and insert in 2 sine of cosine. The sines cancel out, leaving you with 2 cosine of x, and then the antiderivative of cosine is sine. So I'm able to get 2 sine of x plus c. C is very similar to A, where I have to distribute. And then I notice that secant squared, the antiderivative of that, would be tangent. And then the antiderivative of secant times tangent would be secant. And I'm able to get that following identity. Okay, have fun.